All right, first thing we're going to talk about, so we talked about piecewise. We're going to talk about a certain type of piecewise, and we're going to kind of link that in. So I'm glad we spent a significant amount of time because it will make step functions and absolute value functions a whole lot easier. All right, so the first thing we're going to talk about are step functions. And you have probably seen this, but you didn't know what they were called. Okay? So a step function is made up, it's an infinite graph, but it's made up of line segments, or it can be an infinite graph. And so it kind of looks like...
So is this after the function got remarried? Good one.
That was a good one. I thought it was a good one.
Good one, Noah.
We talked about how piecewise shows up. I was going to say, as soon as I put it up here, you're probably going to go, oh my gosh, I've seen that before and I didn't know what it was. So it's definitely a function, and the reason it's a function is, if you look, it's passing the vertical line test, because every time I hit something like this, it's only hitting one time because of the filled-in bubble, right? And so this is what we call a step function. You've probably seen them on standardized tests. Have you seen them before on test? I know you said you'd seen piecewise. It's another type of piecewise, okay? So what this one is this is the most common. It's called the greatest integer function. Greatest integer function. And it looks a little funny. Looks like it's kind of a bolded. Okay, and so what it really means, I forgot to hit record too. Okay, sorry. All right, so let me tell you what this means. So when we do greatest integer function, what it tells me, what it means to do is, this is essentially the same thing as the greatest integer that's less than or equal to x. Okay, less than or equal to x, but it's got to be an integer. What does integer mean? Whole number, no decimal, right? Integers include the negative portions. So if I said that f of x was the greatest integer of x, then what would f of, let's say, 2.3 be? 2. Okay, it's the integer, the biggest integer that's less than or equal to x, so it would be 2. It goes down. Okay. On a graph, actually, let's do one more and see if you understand. What about... It goes to the nearest integer below it.
Just below it?
Just below it, okay? So if this was negative 3.7, yes, it would, Lily. You're absolutely right. It would go to negative 4 because just below it, okay?
How is that?
That's what this function means. Those symbols, that's what those symbols mean. It is, that's because I'm telling you. That just like you know that x squared means multiply x times x, this means take the nearest integer down.
So why are you writing it down like that?
What? Because I told you that f of x equals this. So plug it in. You see what I'm saying? I defined the function first. And then I said, fine. It's the same thing as doing, this is the same thing as, is that why y'all are confused? Yeah. Yeah, it'll tell you, it'll define it. Okay, so tell me that again. It's, okay, so 2x inside the greatest function. So you would multiply 2 times x first. So if this is f of x, then if I want to do f of 2.5, or actually let's make it 2.7, okay? you would need to multiply, because this groups them together in there. You would need to do 2 times 2.7 first, which would give you 5.4.
We just went from not equaling
And now you apply that operation. So it would be what? 5. You see what I'm saying? It's just an operation is what it is.
to. Oh, we did that because it was 2.
Because I changed f to 2x, right. Right. She said what would happen if the 2 was in there. Totally different if I said, yeah, but now g of x is 2 times. Well, this becomes a different problem, right? This becomes g of 2.7 would mean I do that inside first.
2.
Exactly. Okay. It is an operation that you do is what it is. And the operation is the nearest integer below. Does that make sense? Okay. Okay, so the graph part of it, which is really what I wanted to get to too, because we got to talk about domain and range on this too. The graph of a greatest integer. Are y'all done? Okay, go ahead. Go. There's some question on how the rounding is taking place and why, and let me show you what it looks like on a graph, and I hope this will clear it up for you a little bit. If I graph, guys, if I graph this step function, okay, so I've got and I'm going to put a few pieces up here. This one goes on forever. Come on. It's really just little pieces of horizontal lines that are restricted. All right, so let's think about this.
Oh, wait. No, but is it kind of like,
I'm fixing to show you.
is it kind of like, the gold circles are like the line between the graph? If the slope, if it starts at 0, 0, and the slope is x, would it be 1 over 1? It's kind of like that? That's what I'm seeing.
I'm not sure what you're saying.
I see what you're saying. I think I know what you're saying.
This one does, yes. It shifts and all, but the parent function does start out that way. It can equal that, right. F of 0 would be 0. F of 1 would be 1. Right. Because you could, this is going to keep going, just like a line. It's going to keep the pattern going, unless I restrict it. I'm going to show you. All right, y'all stay with me. Stay with me. All right, y'all get so excited when it's something you haven't seen before. Yeah, well, you know what I mean. All right. This also continues this way. Now, I want you to think about this for just a second, because when we think about points on here, this will make sense. If I asked you, what is f of 2.3, what would you tell me? Do you agree? 2.3 happens here, and if I go up, it's at, here's the point, 2.32. Right? You see what I'm saying? Huh? Yes. This point is 2.32. Okay. Because what is, all right, so we're looking at the open dots. What is f of 1? 1.
So is rounding down to the beginning?
F of 1 is 1. You can't do this. But f of 0.9 is 0. So it can get all the way up to 1, but it just can't equal 1 because at 1 it becomes 1. You see what I'm saying?
So is your round down gonna be your y? I mean,
Right, because that's what you're plugging in. What you plug in is x, what you get out is y.
So, yeah, that's what I thought. Like, too.
Yeah.
So, but that's only one.
Oh.
So f of 0.9 is 0, so you got 0.
So
inclusive.
0.90. That's the point. 0.90.
So
Right?
It's basically the same as
Do you see what I'm saying?
So it's literally like x and
Do you
y.
have to
So the
graph
x
it?
and then there's the y and you just plug the coordinates in.
Well, x equals y is a line.
Well, I mean like the x, for the function f of x, the x is the x coordinate and the what equals
What
y.
you get out is y. That's always the way it works. Yep.
Okay, so why can't you do the one?
Why can't you what now?
Do the
So 1, if you plug in 1, you get 1, right? That's why there's a solid dot at 1, 1.
Oh.
It can't be 1, 0 because that's not the nearest integer. 0's two, yeah,
So
okay.
that's what explains the dots. Like,
Correct, closed and open, yeah. The domain would be negative infinity to infinity, but the range is where it's going to get. Range is just integers
would you
because
do
there's no in
unions?
between.
Would you do unions all the way?
Yeah, and it would have to continue.
Forever? Can you say
Dot dot dot
union infinity?
dot dot dot. Yeah, we'll talk about that. Y'all are jumping ahead. All right, I need everyone to understand the step function here. Okay.
I get it.
It's the nearest integer below, okay, and understand the graph the way it looks. Okay.
2.30, comma 2. Why would you not put the dot at 2.30?
It is. Watch. 1, 2.3, up 2. There's a point there. Because that's not the endpoint of that line. That's what your integers are your endpoints. Right.
How do you know that?
Because if you plug it in, that's what you get. Correct.
If integers are whole numbers.
Correct.
So it's always going to be that line, so it's going to be like 1, 2.
Not necessarily. They can shift and change.
So how do you?
Different. I'm fixing to show you another one. This is what we call a parent graph. A parent graph is one that has no stretches, shrinks, shifts, anything on it, okay? If you think about a line, the parent line would be y equals x, okay? Then you start adjusting it from that. That's just a horizontal line like this, right? That's y equals x. From there, you can start adjusting the slope to where it starts moving like this. You can start changing the y-intercept. That's going to shift it, right? So that's the same kind of thing. This is what we start with. This is what we're going to do a lot with parent graphs and a lot of transformations on graphs from parent graphs, okay? This is just a parent graph is without any changes done to it, okay? This is one step function. There are an infinite number of step function graphs we can do. This is the step function, greatest common integer of x. We did another one algebraically whenever we put a 2 in there, okay? It changes the picture. All right? So let me show you another one. Are y'all ready?
I think I should see it more. Is the next one going to show us like the line maybe?
Yes, the next one's going to shift around.
2.32, is that like a solution or is it just like a point?
I think when you see the application of it, it makes a lot more sense than just showing you this way. So let me set up a scenario for you. You decide to tutor your sibling. Okay, you have a little sister that's taking pre-algebra in what, 8th grade? Okay. And your parents agree that they will pay you $15 an hour to tutor. But they're not going to pay you for a half an hour or a quarter of an hour. Okay? And I'm going to say, but what do you think? Would they round it up or down? They'd round it down. Okay.
Frugal parents.
So frugal parents. Okay, so they're going to round it down. So they'll pay you $15 per hour, but they'll only pay you even hour amounts. And they won't pay you, like if you do 3.2 hours, they're going to pay you 3 hours, right? So let's think about what that looks like on a graph. I'm going to be in my first quadrant, right? Because I can't have negative time, and I'm not going to pay them money for not tutoring. So I'm going to have my time on my X because that's what I'm used to doing. That's my independent. That's what I'm going to plug in, right? And this is how much money I make. Right? All right. I'm going to say 1, 2, 3, 4. Some of us get really zealous. We'll do 5. We'll say this is per week. How about that? 15, 30, 45, 60, 70. If you tutor 0 hours, how much money do you make? $0, right? What if you tutor half an hour? $0, right? You have to make it to what before you get paid? 1 hour. At 1 hour, you get paid how much? $15. So all of this area until you get to 1 is $0.
That makes sense.
I told you, let me apply it, and it might make a little more sense. Look at you getting a word problem and then going, oh.
No, as long as you talk about money, we all get it.
Okay.
And we didn't have to figure it
Yeah, but what's that goal?
out. All we wanted money. So that's all we wanted. Yeah.
From 1 hour up until 2, you get $15. But if you hit the 2 hour mark, suddenly that bumps you up to $30. Now, this whole hour, I'm only making $30, but once I hit 3, that's why it's open. Once I hit 3, now, if you had, not that your parents aren't nice, but if you had super nice parents, super generous parents, we'll say, okay, who said, I'll round you up instead of down, okay, your filled in dots and your open dots would be switched. Yeah. Once you get to 1 hour, you get $15. But you have to make it that 1 hour mark first. You don't get $15 until you hit an hour, right?
I don't understand the weird thing
Okay. Now let's do the other way. Let's do the other way because I want you to see.
Wait, so there's only 2 ways.
There's only 2 ways. That's right.
It either open, close, or close.
It can be the greatest integer or the least integer. You'll have to read it. Yeah. So your parents, or maybe we even set up another scenario because when your parents are paying you, of course they're rounding down, right? But let's say you go, what's something you pay for by the hour?
minimum wage.
Let's say you're one of the lucky people who have a maid come to your house, right? And the maid says she's going to charge you $10 per hour to clean. Okay? I know. It's not real. Did you say that's not much? Is that what someone was saying? That's not much, but just for the sake of example. All right, so she's going to charge $10 per hour to clean. If she's only there for 30 minutes,
$5.
she's only getting paid by the hour. You're only paying her in $10 increments. Are you just not going to pay her? What would you pay her? $10. What if she worked 2.75 hours? You'd pay her for 3 hours, right? She's not going to work for free. You're going to have to round up. And in general, if you go like a lawyer or a doctor, like a therapist or anything like that, that you pay by the hour, they're going to round that hour up, right? So it's going to look a little different. So now, at 1 hour, from 0 to 1, what are you paying? $10, right? Even at 0, you're still paying. So both of these are going to be filled in. Notice that. But past that, you see the difference here? Past that, so it's rounding up instead of down.
From 0 minutes to an hour, you're still going to get paid the same way, right?
Correct.
Okay.
But anything past 1, she's getting $20, right? She's not working for free. Nobody's working for free. At 2 hours, she'll get $20, but if she works 2 hours and 1 minute, you better go and get your pocketbook ready to pay another $10, okay? Well, why didn't it? Because
She's not going to
this should actually be an open dot here, because you're not going to pay her for 0. But, yeah, I'm sorry. I got ahead of myself. But at 1 minute in, suddenly she's making $10, okay? Do you see the difference there?
Yes.
On the rounding? Okay. Do you understand the function a little bit better? It's just an integer function. It's finding the nearest integer is what it's doing.
We do one more.
Okay.
I'm just confused on like the here's like X and
This is the function part.
Okay. Somebody said one more. Here's one more. I'm going to read this one straight from your book, so you got one like for your book. An automotive repair center charges $50 for any part of the first hour of labor. Any of the first hour. And then $35 per hour for any part of additional. In other words, you're not going to give them 30 minutes worth of pay. They're going to get paid to the hour, right? So let's graph what this looks like.
And you always round up for a short, right?
Right.
Is it going to specify if it's round up or round down?
Well, if you're paying somebody to do something, you're going to, yeah. All right. Unless it's your parents, that's right.
So unless it specifies to round and to down, you round up.
Correct. Hours. Money. Let's see. I'm going to go by 20s. 20, 40, 60, 81. And these will go by ones. All right, so any part of the first hour, how much are we making? $50, right? Any part of the first hour. So that means any part of the first hour, $50.
Wait, so this
So
one.
if you halfway through 40 and 60.
What is
That's
it?
30. That's 30.
Ah! 50, thank you. That's an open dot. Because 0, I mean, can't be 0, right? All right, any part of the first hour, $50, done, right? 35 after that. So how much would it cost you for 1 hour, for let's say 1.5 hours worth of work? $85, right? So I need to go up to 85. This is open. This is closed. How about the next one? Another $35. What are you up to? 110? What was I at here? 85 plus 35. Open. Closed. Does that make sense?
Yeah.
No?
Yeah.
Where are you confused?
I think they're going on.
All right, say that again. If what now?
If you're getting $10 an hour to do something, but your employee, you only work for 30 minutes, what if your employee just gives you $5?
Isn't it important
save for
to
them to save money.
Yeah.
It just depends. So this problem is written as a labor problem. So whenever you're paying somebody to do work for you, like an individual going out, like I'm gonna pay you to build a deck at my house. And I'm gonna pay you by the hour. They're gonna round to the nearest whole hour. Or you go to an attorney, they charge you by the hour. They're gonna round to the nearest hour. They usually, some of them will do half hours, I think, but. Yeah, but this one laid out, it said, any part of the first hour and then $35 for any part of each additional hour.
So, but why would you go all the way up to 2? Like, if it works an hour and 1 minute, why would you go all the way up to 2?
Well, an hour and 1 minute is here, right? So an hour and 1 minute, he would get 50 plus 35, which would be 85, which is here.
Instead of just 50.
Right, because once you cross over that 1 hour mark, you're paying another $35.
What if someone paid a year? I don't know, I'm just thinking about that.
Yeah.
Cause like, I think my dad can pay, he can pay like a year.
Well, I don't think they'd pay you for a whole year's salary if you just work like a day of the next year. Be nice, though. All right. Yeah. Do you have a question, Lizzie? You don't want what? Good. All right. One more piecewise function that we're going to talk about. It's my favorite. I just love math. Y'all leave me alone. Because math is always math. It doesn't change. It's always, it is what it is. It is logical. It makes sense.
I don't like crap. I like literature. You can have multiple answers.
That's
one thing.
why. Tell me this. What does absolute value mean?
Biggest
It's the absolute value.
The biggest like possibility
It is. Biggest positive is like it's the absolute value.
Y'all, you're thinking right. It's positive. It just only thing absolute value does to a number. It is 2 little lines. The only thing absolute value does to a number is make it positive. Okay. So the absolute value of 5 is 5. But the absolute value of -5 is also 5. All it does is make it positive, okay? It is an operation, okay? Just like the step function was an operation, it does something to the value. They rounded it on the step function on this, it makes it positive every time, okay?
So if we were to graph this, it would just be the first quadrant?
Well, let's think about it.
Here we go.
Because it'd be -5, 5, right?
So, yeah, so think about it. If I had f of x equals the absolute value of x.
So it would be the top.
So let's think. Let's look at it graphically. That's right. So it's going to be, it would be 5, 5, but it would also be -5, 5. Right? Well, close. What about 0? What's the absolute value of 0? 0. So it's a line. If you think about this line, the line y equals x, right? But all the negative parts are flipped up here. So we can write this as a piecewise function.
Wait.
Wait, how did you get
The absolute value of 0 is 0. Yeah.
So do you have to do this?
It would what? The line, guys, I feel like I fight y'all when I'm giving you something, and I understand you don't know how to do it yet. This is the first time you've ever seen it. You wouldn't know how to do it. Give me a chance to teach you. Give me a chance to explain it. The line, this line is y equals x, okay? If you were to take off all the negative portion and instead make it positive, it just flips it right up here. Okay? So that's why that's what the graph looks like. Yeah.
So to get 0, 0,
Always.
So it's just like a minus symmetry?
It is symmetric. It is
Is it
symmetric.
always going to look like that?
No.
Like,
So do you
But
always?
is 0, 0 always going to be the
No.
first one?
You can get like absolute value like X.
Y'all are doing the same thing you did with the step function.
Sorry.
It all
How do you get 0 to 0?
It all depends on your this is a parent graph. Nothing has been done to it. I could have different values in there. I could have the absolute value of x plus 3, a 2 out here minus 5. It's going to look different. Okay? It's not going to look like this anymore. It's going to be shifted. It's going to be moved. But this is where it all starts. Okay? This is just the basic function. Yeah. It'll always be a v. Yeah. It'll always be. That's where you start flipping from positive to negative there. All right, let me show you, because the point of this was that I show you the piecewise part of it. Okay. If I'm thinking about f of x equals just x, right? Right? Because that's the original line. That's what I have. So f of x equals x. That portion of the green line is still there when x is positive, right? Does that make sense? So when x is greater than or equal to 0, it's still that line, right? But what about when x is less than 0? It would be negative x. Good job. That is the graph of it. We've already graphed it. We graphed it first. Yeah. Okay. That's saying, think about it. What is, if f of x is the, and y'all know this, but this is just showing you how piecewise works. What is f of negative 5? The same one we did. It's 5. It's the opposite of what you plugged in, but only when you plug in a negative is it the opposite. Right?
Why is it not?
It's only, so putting a negative sign in front of x just says opposite, right? Do the opposite. If it's positive, make it negative. If it's negative, make it positive. The only time absolute value changes anything is when it starts out negative. If it starts out positive, it stays the same, right? What's the absolute value of 5? When did I change the sign? When it was less than 0 in there, when it was negative. So therefore, when x is less than 0, change the sign of x. But when x is bigger than 0, keep it the same.
Wait, less than 4. X plus.
It's not going to be as long as this is just absolute value of x.
Oh, we're gonna move away.
We will move, yeah. Huh?
Of
The
that
parent graph, right. That is the definition of the absolute value of x. That is the textbook definition of the absolute value of x. Textbook definition of absolute value of x is f of x equals x when it's bigger than 0. F of x equals the opposite of x when it's less than 0. Okay? That is just,
Because it's part.
right, so you do the two pieces there. Yeah.
Okay, so on the graph, disregard the green line, and that is the graph of that.
Yes.
Okay.
Yes.
I think we do try to plug numbers in.
Well, but I'm not teaching you shrink and stretch just yet, so you're going to have to plug numbers in for this to find it. Okay.
Because like that question I just asked.
So when x is greater than or equal to 0, it's your y with x. Right?
Yes.
And but
Yes.
whenever x is less than 0, it's
That's when you negate
goes
it.
down, but you got it.
Right, because it flips. Does that make sense? Okay. Looking at this parent graph, what is the domain? Yes. Is there ever any x that you can't plug in? No. You can plug anything in to get a y value, right? The domain is not restricted at all. It's negative infinity to infinity. What is the range?
0.
Bracket or parenthesis? Why?
Because it can go
It includes it. Y'all okay on that?
Yep.
Would it ever not include 0? It's always going to include the vertex, that point where it flips, it's always going to include that. All right, here's the thing, as you graph absolute values tonight. You're going to have to find points. One of those points is going to have to be where it meets, and that may or may not be at 0. So let me give you an example. In fact, let me do one from your homework. And we're going to do the domain and range on all of these as well. Let's say I asked you to graph okay. So I need to start finding some values, okay? Because I need to find that, right? Any guesses what I should plug in?
0.
I hear 0, I hear 1. Let me ask you this. Do you agree that the point that it starts changing is when you get negatives inside that absolute value? What point would I start getting negatives inside that absolute value?
But it's an
Negative
absolute value.
Negative 4 would give me 0. Negative 5. Negative 5 is where things start getting wonky, right? Because at negative 5, I got a negative inside the absolute value and it's got to flip. So, instead of picking all these random numbers, what if I made sure and picked negative 5 and negative 4, because that's going to give me 0, right? And maybe go the other way too, a couple of positive ones. So I'm going to go negative. I'm going to stay close together here. Okay. Do you see what I'm doing here? I'm forcing it negative. I'm saying at what point does this become negative inside the absolute value? Because that's the point that it's really going to start.
But then, so once you get in there, you gotta flip it to the absolute value.
Huh?
Because you're saying like negative 5.
Because the graph of absolute value changes from a linear function and starts becoming crazier when I get a negative under here. If there's not a negative inside here, then it's just the graph of x plus 4, which is a line.
But don't we have to graph that anyway? Don't we have to?
You do, but if you kept it going, you can't, once you get to the point where there's a negative in here, it changes to positive. So what's the first time it becomes negative in here? At negative 5. Because when you plug negative 5 in here, you get negative 1, which is 1. Right. If I put negative 4, I get 0. If I put negative 3, I get 1. If I put negative 2, right? So if I graph this, hopefully I will see the flip, the change, where it V's, right? 1, 2, 3, 4, 5. Negative 5, 1. Negative 4, 0. Negative 3, 1. Do you see it's reflected itself here? Negative 2, 2. And if I went out negative 6, I'm going to bet it's going to be at 1, 2. Negative 6 plus 4 is negative 2, which would give me 2. I can see the graph now. You've got to have enough to pick up. You've got to go far enough to where you can pick up. This point has got to be on your graph, and you've got to have at least 1 point on either side of it. You gotta know where it flips. You gotta know where it flips. Where it changes from negative to positive. What do you have to put in here to make it negative? Mm-hmm. Yeah.
Negative 5, I thought it would be negative.
It would, but what does absolute value do? Okay. What's the domain here? You can plug anything in for x, right? If it's negative, it's going to flip it, but you can plug anything in. What's the range? Absolutely. Yeah? Want to do one more where it moves, shifts some more? No. Because it might not be sitting on the axis, y'all. It might be that that vertex, that point where they meet, happens over here. Okay. All right. Let me give you your homework.